Welcome everybody to building our third part in a three-part series of building AI products. Part 1, 2, very NLP focused. We looked at OpenAI, all the GPT-3 stuff, GPT-4 stuff, really great. Catch it later if you haven't. Then we looked at Hugging Face, the world of open source, and how we can actually build AI products there. But again, NLP focus. Today is the day for all of you computer vision fans out there. We actually are going to talk about computer vision. And when I think about computer vision, first name that comes to mind is NVIDIA and building on Azure. So in today's workshop, we're going to look at how we can build computer vision products with NVIDIA and Azure. Here we go. But of course, quick intro video. And we are back. So like I said, we're going to be building computer vision products using NVIDIA, but I'm not going to do this alone. I have a real pro to join me at today's workshop. It's Abu Bakr. How are you, Abu Bakr? Coming from NVIDIA.
Hi, good evening. Nice to meet you, Bray.
Perfect. So I want to know, this is always fun. Hopefully we get some good responses of, where are you joining from today in today's workshop, and what's your AI experience? Abu Bakr, I'm assuming you have some AI experience. You wouldn't be here without it, but how did you sort of get into the world of AI? What brought you here?
Oh, thanks for hosting this. My name is Abu Bakr currently, and I work as a senior solution architect in intelligent video analytics within NVIDIA. And basically, I support Europe, Middle East, and Africa, all the customers who are doing training, optimization, and also deployment of their computer vision solution. So enterprise-grade computer vision pipelines, I would say. That's what I'm doing at NVIDIA. What got me into AI, it's basically a very long time. When I was doing my bachelor in biomedical engineering, I took a course in image analysis, and that was the first thing that I took in image analysis and computer vision, and I fell in love with the technology. And then it started from there. Like I specialized more in computer vision, and after that, I joined Microsoft Research for a while, Research Institute of Sweden here, and then finally NVIDIA here.
Very nice. And I'm sure what you were doing in your coursework and master's, the technology has not changed, right? It's just doing the same thing, right? Nothing has improved. Yeah,
Wow.
it's insane.
Yeah.
Cool. Let's see. So we have a local hacker, Sweden born hacker. So I guess you've just been always doing hacking and AI work. And Mervyn has a question for us. Is this only streaming on YouTube? Yes, it's only streaming on YouTube at the moment. This will also be on demand later on when after the recording will be out. We'll include that into the links as well. But yeah, do let us know what your AI experience is, so we get a good group going. I'm gonna start it off first though. So I have this really weird problem with my PowerPoint, unfortunately, where I can't go in this like proper full screen mode. So I'm doing the best I can with this like half full screen mode, but obviously that's us, that's our beautiful faces. But one thing I want to show you is not us, because you can see us already. So we are going to share a few resources and links. Abu Bakr is going to walk through a demo and actually some code as well, I believe. And I know it's kind of stressful when you sit on the side of the video and you're like, oh, what's the link? Or how can I find this? So I've gone ahead and I've put in all of the links and all the resources that we're going to share today in this one little kind of page or repository, if you will. So I'm going to put that in the chat as well, so you have it. But again, so no stress. You will always get access to everything there. And within this link, we actually have not one, but two Microsoft Learn modules for you today. So I'm a nice guy, so I'm going to give you 2 free resources that are always available anyways. But one, it will be working with this general computer vision in Azure, and another one is actually going to walk directly into what we're talking about in today's workshop, which I'm not going to give any spoilers. I'll let Abu Bakr take us away on that. But that's where all the links is. That's where you'll be able to find all the resources that we're going to walk through today. But without further ado, you obviously did not come here to hear me talk. You came to learn about building computer vision projects with NVIDIA. So Abu Bakr, I'm going to give you the wheels to the StreamYard screen here.
Thank you so much. So welcome everyone to this introductory talk about how to build computer vision applications with NVIDIA technology together on Microsoft Azure Cloud. So within this talk, we're going to talk about how to build computer vision, how to train a model, how to optimize the model, and also how to deploy it and manage the deployment later with Azure IoT Hub, for example. The first thing to start with here is a motivation for computer vision. Like, if you are interested in AI, if you're interested in computer vision, you probably know a lot about the applications of computer vision right now with the increasing amount of cameras or the increasing numbers of cameras that are being deployed everywhere. There is a lot of streams that comes, and basically there's a lot of data to be processed. And all of these data are beyond our human brain capacity to process ourselves. So we need a machine to process this, a reliable machine. And the applications for this can range from smart cities, where you can monitor spaces and make it safer, from retail, where you can analyze also the retail itself and design your product in a better way, or see which products are getting more attention. In healthcare, in robotics, video conferencing also is on the rise right now. And the list goes on. Industrial inspection is one of the hottest topics in computer vision, where you can monitor the product line and look for defects or look for safety within product if the employers or the workers are wearing protective equipment. And retail assistance as well, it belongs to the retail. So the applications of computer vision is basically very wide range, and the potential here to build a computer vision pipeline that's worth a lot is huge. But the thing is, when you are trying to build a computer vision system, if you are a developer in the middle of this, or a software engineer or AI engineer, you always face different kind of challenges. And these challenges start from the beginning. How can we start with the data? Do we have enough data to train our models with? Then which framework are we going to use to train? What are the features that does it support? Then we have the architectures. We have several architectures, ResNets, BGGs, transformers right now. We have different technology, transfer learning, self-supervised learning. Which one are you going to choose as a base model for your application? And then you have the optimization. Once you have trained the model, how can you make it faster? And how can you make it smaller? What kind of deployment do you target? Do you target embedded device? Do you target a workstation? You need to tune your models basically to work to a different scenarios. And also, what are the deployment options? Are you targeting Linux deployment? Are you targeting Windows deployment? That's also a thing. Are you targeting embedded device again deployment, or workstation, or server, or a cloud? So all of these are challenges and also are options to choose from. And within that, we have a solution for all of these challenges. So basically, from NVIDIA, we have an edge-to-edge vision AI software SDKs that help you train and deploy and monitor your application. Starting from the beginning, we have on NVIDIA Omniverse Replicator, where you can use computer graphics to generate automatic to synthesize data and it's a process called synthetic data generation with a replicator. So basically, you can start with a model, and basically you can change the background and do some randomization to this process, to this automatic data generation process, and then you will end up with labeled data without any labeling effort. Then you have, after you end up with data, you have TitleKit, which is our tool for training. It is also bundled with pre-trained models that you can fetch from NVIDIA NGC, the NVIDIA GPU cloud. It's a repository where you can find a lot of models, a lot of containers, a lot of Helm charts that you can grab. And also, after the training, we have tools for optimization and deployment, which is basically you have NVIDIA TensorRT, which is our runtime engine. We have DeepStream for pipelining. We have Triton Inference Server for hosting multiple models. And also we have Metropolis microservices we're going to talk about later. This is our libraries that we are going to talk about within this talk, and we will know which one is which when it comes to building a computer vision pipeline.
I've got a question, Abu Bakr.
Please.
Yeah, so these libraries and I guess SDKs or tools, are they language specific? Or I mean, I'm a Python developer, I know Python at least. But if I wanted to be, if I was a web developer or something, would I have to have access? Like, could I access these tools, or which ones are available for, I guess, general use?
Yeah, so Python right now is very popular among data scientists and machine learning developers. So basically, all of these tools work with Python. When we talk about TitleKit, TitleKit is a command line interface. You even can just run a command. DeepStream works with Python, C++, NVIDIA Storage Toolkit as well. So basically, all of them supports Python and C++ to think about to start with.
Nice. There's always one C++ person joining the stream, so I'm sure that one person who has heard that good news will be excited. But that's awesome that you have support for it.
Yes, and we have NVIDIA Fleet Command, which is Fleet Command. It's a managed tool to manage different edge devices. If we took like an architecture look on these tools, it's going to be organized like this. We have the NVIDIA drivers on the bottom, and on top of it we have the TensorRT. TensorRT is a runtime engine for an AI model. So think about it like you give it a model, it makes it run. And we have Triton Inference Server. Triton Inference Server is a software tool that allows you to host multiple models at the same time, prioritize one or two, and manage basically this kind of architecture as a server client application. And then we have DeepStream, TitleKit, pre-trained models. Within this talk, we're going to talk about the pre-trained models, TitleKit, and DeepStream. And basically, DeepStream uses TensorRT and Triton Inference Server. So basically, we will have a holistic overview of everything here. The good thing also about this is we have one name for it. It's called Metropolis. So Metropolis is the ecosystem of these software together. And also we have a set of partners who are developing their solutions with it, and also who can help whoever wants to develop a solution with these tools. There is also a good thing about having this technology is basically it works on everywhere. So basically you develop once and you deploy on Jetson devices, you deploy an EGX server, and also you deploy in cloud with the same software stack. So how the workflow goes with Metropolis? Metropolis is the ecosystem of these software tools. You start usually when you are trying to build build an AI application for computer vision. You start with data and model selection. Then you do the training, and then you do the deployment, and finally you do the management. And that's what we are going to do today. So If we started by the model selection and treating the data, so if you went to the NGC, you will find a lot of different models that you can find for different use cases. You usually have two kinds of models. The purpose-built models, which is trained towards a specific task. And these models, let's say, for activity recognition, for body pose estimation, face detector, pedestrian detector, vehicle make detector, something like that. So it has a specific task to do. This is the first category. The second category is a generic model. And these generic models are trained on a generic data set, something like ImageNet, for example. So it can recognize maybe 500 classes. It has great generalization when it comes to features. And then you can base your development based on one of these two categories. When you go to NGC, you will find all of these models. You can browse the catalog, choose the models that you want to have. When you open the model cart, you will find information about the accuracy and also the data sets and also the architecture of this model. It's highly accurate models. It matches the state of the art for each model that's trained. If it's not better, we have the models that is trained on NVIDIA proprietary datasets and also benchmark datasets. So if we looked at the coverage of these data, of these models, you will find that the models for computer vision basically covers image classification, object detection, and semantic segmentation. This table is around 3 weeks old, and right now we have also transformer models that you can find on NGC. So the table is growing with time, with every new edition of Toolkit, and also with every new edition in the field. So whenever you find something very successful in the market, in the research field for computer vision, you expect it to be here. We have image classification, object detection, and segmentation in different backbones for it. This is an overview of the generic models. But the list also goes to purpose-built models. And these purpose-built models, you can find information about them. This is a snippet of it. So basically, the list is very long. And you can find also the performance of each model across different hardware. So as a starting point, choose a model from here, and then you can train it on your own data. This is the fastest way. And how can you train it with your own data is by using TulkIt. So TulkIt, it's an abbreviation for train, adapt, and optimize. Toolkit, then. And then it's by definition, you can use it to train and adapt and optimize the model that you're using. Usually it starts with, you can bring your own model. So if you have a model Onyx format, you can bring it to Tau. Otherwise, you go to NGC and find the model that you would like to start with, whether it's a pre-trained, a purpose-built or generic, and then you use it with TulkIt. The first feature that's worth mentioning here with TulkIt is logically the data processing or the data augmentation techniques. With TulkIt, if you have a small amount of data, you can do this kind of data augmentation techniques like blurring or spatial transformation or color shifting that enlarges the amount of data that you have and augment it to have a huge amount of data. And you would think that this is very simple, but actually it's very effective. Think about, for example, the horizontal flip here. If you have a data set for right-handed activity, for example, if you just did a horizontal flip, all of a sudden, basically, you have a data set for right and left hands. And for a very simple application like this, you can get a huge amount of data. Think about color shifts when it comes to vehicle, for example. or basically zooming when it comes to obscuring the objects. So all of these scenarios are very helpful when it comes to a computer vision application, but also you have to know a little bit about the problem, because sometimes you will not make use of, let's say, vertical flips if you're doing pedestrian detection. So yeah.
Nice. And did you say that like the Toolkit has this sort of built in to perform data augmentation, or like what do you suggest is the best way that people can get started with doing data augmentation? The tools, I mean, obviously some of this is kind of maybe easy programmatically. Also, like to your point, to your use cases, like that's a really good point, right? Some of you might want to augment, but they might not have the right use case. Do you have any like tips around that?
Yeah, so TitleKit basically have this tool, this feature within it. It's a command line interface, so basically you can just write the simple command of it, and it will augment it for you. You have also use cases on notebooks. You can use that. It has been there since very long in computer vision. Like since I began with computer vision 12 years earlier, data augmentation has
That's
been
like
there.
1,000 years AI years, but yeah.
Yeah, that was only image analysis time. So basically, a data augmentation has been there since the beginning. But right now, you have a lot of tools that can support it, and one of them is TAM. Yeah, for sure.
Nice, awesome. That's good to hear.
So right now, you have chosen a model. You got it from NGC, or you have brought your own Onyx model. You have a small amount of data. You did a data augmentation. So what can you do? What can you do to train your model? With Toolkit, it allows you to do a transfer learning towards one or two, or basically the main two tasks you can do. The first thing is adaptation to a different scenario. So let's say you start with pedestrian detector and you'd like to detect, again, pedestrian, but in infrared camera. So you have collected enough data with infrared cameras and you want to use it for that. So basically it's a command line. You will just set the configuration of the model that you have downloaded and the infrared data set. You put it together, you will end up with a model. As simple as this. It uses transfer learning. So basically it starts with the model, you cut the last layer and retrain it towards your goal. And it has been, like transfer learning has been leading the state of the art just before transformers for a very long time. And also, it has been proven that it's always more successful than starting from scratch. So if you have a look here at the convergence of each models, you'll see that the green one, which is a transfer the transfer learning based approach, is always winning when it comes to starting with data. So yeah. And also the second thing, if you, for example, had a model and you have trained it already, let's say you have a model to trained on vehicle types in the street, you have trucks, buses, and vans, and all of a sudden you started to think like, yeah, I need to add a classifier for, or a detector for ambulances as well. You don't need to change the whole architecture again. You can use Toolkit and transfer learning to add one class. In this example here, we are adding a class, and we have the white paper for it and also the Git repository. We have added a pedestrian. We have used a pedestrian detector, and we have added, for example, a helmet detection to it. Again, it's going to be a command line. You just type a line and then set the configuration for the training. So this is
we
for the
actually
training,
have some questions. I think I love this. This is why we're all here, because like when we get very like specific use case questions, because that means someone's building something and they want to know how it works. So Siegfried, I think that's how you say it. Sorry if I did not say that right. Wants to know what's the status of object detection and classification with regards to binocular vision.
So what kind of task do you plan to do within binocular vision?
I think so. So they've expanded a bit. So
Yeah.
if we perform object detection with two images that represent the left hand or left eye and right eye, they want to know if they can match these objects detected with the left eye, right eye, and then triangulate how far or the distance of that object, I guess.
Yeah, that's a field of its own right now in computer vision, the depth estimation. We have products that has been there. Actually, I did my graduation project in this, again, 10 years ago, 12 years ago. So basically, the first thing is, yeah, you can use both of them to triangulate using the two matrices that transform the scene into the image plane. Technically, you can do that with geometry and also with features or with key point detection. But right now, you can do it also with deep neural networks, and there is a lot of publications on that. So basically, dense estimation with neural networks. There are different approaches for the same problem, like Kinect, for example. Kinect, instead of using two cameras, it uses infrared pattern projector and a camera to capture on the other side the pattern, how it was spread on the field. Again, it's another way of doing the triangulation. So to record in 3D, yes, there is a lot of approaches over here. There is also approaches on detection of or recognition of the 3D or generating the 3D map from a single image based on the data that you can have, and that's also another approach that you can have. So the field is huge, and there is a lot of papers on that. Yes.
Nice. And if you know any good papers, Abu Bakr, I can put that also in the links pages for Sigrid to check out or anyone to check out. But yeah, great question. And yeah, feel free to follow up if you have any more questions. There is no limit here on the amount of questions you can ask. There is a time limit on the amount of questions we can answer, but we'll try to get to those.
Yes. Awesome. So yeah, now you have trained a model. How can you optimize this model? So TitleKit, again, allows you to do some more optimization to the model. The first thing that you can do is model pruning. And model pruning is when you have a model, and traditionally, if you looked at the distribution of the weights within each model that you have trained, you will find a huge amount of weights just squeezed around zeros. And what does it mean? It means that every single calculation, when you multiply the input to the weight, it's just zeros because you just multiply by zero. And if across all the architectures, across convolution neural networks and transformers, the pattern is the same. The most when you plot the histogram of the weights, you will find that a lot of weights just squeeze around zeros. If you just omitted all of these zeros, you will end up with a lighter model. It's going to be a sparse model, and also it's going to be much faster. And in practice, you can see that with pruning, with just cutting these layers off, you can get 8 times smaller network, and also you can get a boost up to 2x in performance. And when you think about 2x in performance, it doesn't only mean that you will have a faster model by a factor of 2. It also means that you're cutting your cost by a factor of 2. Because right now, if you can process one stream on a Jetson Nano, for example, and you can see in front of you here, right now you'll be able to process 2. So you're cutting the cost by half. Again, and also that's also a command line thing. So basically, you set a configuration for pruning, and you can do it with it. Then you have quantization, which is, I think, one of the most popular things to do with computer vision models. So instead of doing floating point operations on 32, you can just do it on 16 or int8 or int4 according to the hardware support that you have. And this also can get you up to 8 times faster in terms of performance when you also increase the batch size of the pipeline. With Toolkit, you have quantization aware training, so you don't lose in the accuracy when you do the quantization afterwards. Also with Toolkit, it allows you to do automatic mixed precision. And for that, it can reduce the time to train the model by, for example, here, from 28 to 18 in this example that we can see. And it's doing this by selecting different layers to run on FP32 and selecting the layers that doesn't require this kind of resolution to work on FP16. And by doing that, you utilize your GPU better, and also it makes the time for training much lower. Also, Toolkit integrates with TensorBoard, and this is a very nice tool that works with TensorFlow. It has been popular in computer vision, AI in general, where you can see the process of the training itself. You can monitor the validation, you can monitor the training error, and also you can see all different aspects of training and parameters on display. If you're just using TensorFlow, then this would work for you as well. So how can we start with Toolkit? We have talked about it, we have talked about the feature. Right now we want to train. So Toolkit works on everything. It works on-prem if you have a computer with the GPU. It works on AWS, Azure, and Google Cloud, so you can find it everywhere. It works on servers, it works on workstations. So you will not find any limitation here. When it comes to Azure offerings, you will find different machines that can support the training workloads. You have the NC machines, you have the ND machines, and also you have NB machines. But the NB machines basically are tailored more towards visualization. Still, you can use it, but I would recommend you to use the ND machines and NC machines if you are using that for training purposes. And practically, to start with it, what you will get is basically you first go to your Azure account, you will create a virtual machine, and you will create the virtual machine that has a GPU on it. Once you are done with that, you will start with NVIDIA GPU optimized virtual machine image. You can get this image from NGC, but also it's available in Microsoft Azure store. You give it a name, and basically you choose a location, and finally you can choose, you type NVIDIA, you find here the NVIDIA virtual machine, you select it, it gets deployed in your machine, and you write your SSH. Yeah, username Karali, don't use it. So basically,
I'm not going to stop you with the Azure talk.
Yes.
Don't let me stop you. I'm not that person. But yeah, just to follow up on the distance detection or estimating the distance. Was there any libraries or Python libraries or tutorials that you know of that could help Siegfried out with their problem?
Yeah, I
anything
can
within
look
NVIDIA.
at that and share it with you. There is a huge field of research. Like I can get you a lot of GitHub repository afterwards. Yes.
Nice. Okay, look forward to that. Thanks.
So yes, yeah. So this is how to start. Like this is how to start your virtual machine and basically deploy the image. This image comes with all the necessary tools to run NVIDIA workload on it or Toolkit. And also here it gives you which machines are compatible with it, the NC, and also the ND series. Then After you have done that, when you start your machine, first thing you do is to SSH to this machine. The SSH, basically, you go as a root if you want. You set up the Python environment, which is very simple. Also, we install prerequisite library, Jupyter Notebook, and NVIDIA Python index. Then you install with pip install. And the quickest thing to do with Tau is to download the notebooks. So Tau comes with notebooks for everything you want. If you need a transfer, if you need to train a classifier, if you need to train an object detector, if you need to train semantic segmentation, you will find the notebook, an example how to use it. So first thing, or the last thing here, after installing TitleKit, you download the TitleKit examples. You will get it here. I can skip. And it's going to be a Jupyter Notebook. When you open the Jupyter Notebook, as you can see, you'll find all of the examples, whether it's classification, detection, semantic segmentation, mass CRMs, YOLOs, also purpose-built models, emotion, efficient detection, FaceNet. So you'll find everything there. When you open the notebook, you'll find information how to set up, how to get the model, how to evaluate the training, and also how to optimize it with pruning, with quantization. So yeah, as simple as this. This is how to start with TitleKit for training. But computer vision is not only about training. Computer vision is also about deploying the model. So to deploy the model, it's a multimedia process. Because right now you have a model, you have trained it, you have all the knowledge you have in computer vision, and you put it into one thing. You have a model that's very optimized and very performant. Right now you want to deploy it, and it's going to be a multimedia problem because you need to interface camera, you need to get up a stream from the camera, process the stream, send it somewhere. So basically it's multimedia. And for that, we have DeepStream. And DeepStream is a tool for deployment, for deploying computer vision application, or sorry, deploying models. So you take the model from TitleKit, let's say, also it works with TensorFlow, PyTorch, all of these benchmark libraries. You can get the model from there. You plug it to DeepStream, and DeepStream accelerate the whole pipeline for you, from interfacing the camera to getting the outcome or generating the analytics.
One question we had, Abu Bakr, we had Adnan had asked basically what you just showed today, like installing Tau and the CB task, if that could be replicated, or duplicated on Jetson Nano instead.
Technically, you can, but would you really want to train on Jetson Nano? Like the training process, you need to do it on a powerful machine because it's a heavy process. I would recommend you to deploy a Nano if you would like to deploy a very light model that's not going to be, performance or memory exhaustive in production.
Got it. So, possible, but not highly recommended. That's always a good tip.
Definitely. Yeah.
Okay. Hope that answered your question, Adnan.
So DeepStream, again, it accelerates from sensor, from camera interface, decoding, which also it's a very heavy process, pre-processing of the stream, the inference itself, which is a model tracking, let's say, if you need that, and business analytics. The good thing about DeepStream, it accelerates everything on its respective piece of hardware on the GPU. So if you're doing, let's say, decoding in a traditional way without DeepStream, you will do the decoding on the CPU. And once you decode an image on the CPU, you will send it to the GPU. And then it will be processed. But with DeepStream, you do the decoding on the decoder's chips on the GPU. So basically, everything runs on the GPU. The frame is there. After that, you do the pre-processing and patching, which also happen on the GPU, the CUDA cores. Then you have the AI inferences, which runs on the tensor cores in terms of GPU and deep learning accelerators as an option on Jetson devices. Then you have the tracking and business analytics. So everything runs on its respective part of the GPU. So you make sure that you utilize the whole GPU, and also you make sure that you do a zero memory copy or minimal memory copies. A zero memory copy is basically because you don't transfer the frame within the GPU, you just transfer the pointers to the plugins. So basically, when you capture the frame, you generate the buffer, and then the decoders, basically the decoders is when you have the frame, then patching shares the reference to the buffer, inferencing shares the reference to the buffer, and then basically all these plugins shares the references. So you don't transfer memory within the GPU. And that's actually what makes DeepStream very fast and efficient in terms of deploying a pipeline. The other good thing is it takes all of these engineering workload off your shoulder. So you just can focus on building a high performant or more efficient model. And you shouldn't care about anything else when it comes to deployment. DeepStream also comes with Kubernetes support, so you can have it within Kubernetes. And also it has a lot of features when it comes to cloud integrations, you can see. So we end up usually with a scenario like that. When you have deployed the model, you have the first thing, if you're using the first line, if you're using CPU only, the second line, which is very popular, to use a CPU pipeline, and you do inferencing very fast, and then finally you deliver your results. And with DeepStream, the latest, or basically the bottommost pipeline, is accelerated all of it on the GPU, which leads to a faster pipeline. So how can you start with DeepStream? DeepStream is, you can start with it with Python, you can start with it with C++, and also you can start with zero coding pipeline. So if you don't want to code at all, you just have a graph composer, something with a GUI, you grab the plugins, you connect the plugins with each other, and then finally you have a pipeline. With DeepStream, you can have cascaded classifiers. Let's say you have a vehicle detector, and then you want to follow it with a vehicle make and vehicle color, and maybe tracking as well. So you can have cascaded classification and cascaded detection with DeepStream. But also you can have a parallel detectors as well. So you can, let's say, have 8 cameras monitoring a pipeline on a factory. 4 cameras will monitor the color of the object. 4 cameras will monitor the goodness of the object. And you can run parallel architecture for parallel pipelines with DeepStream. Also, DeepStream, since we're talking about how to do it with Microsoft Azure, DeepStream allows you to integrate and send the messages with Microsoft Azure IoT. So basically, you have the MQTT server where you can send all of these MQTT messages to Azure IoT. And also with Azure IoT Hub, you can provision the device, whether it was Jetson device or workstation, Edge workstation, as a device on Microsoft Azure IoT Hub. And with that, you can roll updates to it. You can monitor the health of your device. You can provision, let's say, 1,000 devices and have like a command center monitoring all of these devices. And in the links that Corey shared with you, you'll find also information about how to deploy DeepStream with Azure IoT. Yes, me share it again. So yeah, so we have talked right now for 45 minutes about what is Metropolis and also what are the tools that we can have. What is the workflow? Then the workflow is like that. You can start with a model and your own data. You also can start with Onyx models. You use TitleKit on Azure. You grab the virtual machine image and you start downloading the notebooks, and you start with one of them. And finally, you deploy with DeepStream. And again, DeepStream, you can use it with Python, with C++, and also with Graph Composer. DeepStream also comes with pre-built applications. Basically, you can just get one of these applications, swap the model with your model, and make it work. These applications can range from all of the scenarios that you're having, whether it's cascaded classification, parallel classification, dealing with multiple inputs, dealing with multiple outputs, having different sources, videos, RTSP streams, and also having different outputs, also sending RTSP streams, displaying on images on screen, or sending to a cloud. So to start also with DeepStream, you download DeepStream, you'll find the applications for it, but also you can have a look, or basically a training at DLI. And the DLI is a Deep Learning Institute. It's a rich repository from NVIDIA. You can find a lot of courses, a lot of talks, and also a lot of books there. There is paid courses, and also there are a lot of free courses. Specifically for computer vision, we have this list for training for computer vision and smart spaces. You can find different courses, tackles from CUDA and CUDA on Python, Rabbits for data science processing. And then basically you have video analytics, DeepStream, multiple GPUs, concurrent execution. You have TensorRT, a lot of workshops. We also have instructor-led workshops, something like the one that we have presented on the GTC, if you have attended that GTC, which also tackles different topics in computer vision and AI. And yeah, today we have a free course for you. So yeah, probably I didn't include the link here. So yeah, please keep this this code and use it in NVIDIA DLI events. I will show you in a bit how to do it. So again, take a screenshot or write it down. This is free for today, so please take it and at least register today, and then you can take it later.
Okay, so it only lasts 24 hours from now, or basically.
Yes.
Yeah. I feel like a salesman. I like, go buy now before the deal ends. But yeah, I'll put this in the chat and I'll put it up here. So hopefully that's right.
Super.
DIS risk. Lovely. This is the goods of coming to the live stream versus the video on demand. This won't work for people watching 6 weeks from now. Thank you everyone for coming.
So yeah, basically this is a free course that you can register for right now, and then also you can browse the catalog of other free courses if you want. So yeah, so right now we have talked about everything when it comes to building computer vision application, training, optimization, deployment, synthetic data generation, courses, everything, and also the hardware support from Azure and how to integrate with Microsoft Azure IoT Hub. So yeah, if you have any question, please.
Yeah, that was very well done. Thank you for this. Is hopefully people are clapping at home. This is me clapping for you, for them. But cool, yeah, that was awesome. And I mean, we got through a whole AI talk without talking about a large language model or GPT-3 or some GPT-4. So that's also a major plus for talking this specifically about computer vision, because I think that's still a very exciting space to build in. And it sounds like some people are working on some very interesting stuff using this like distance detection and whatnot. I'm curious, like, as your day to day, like, do you get time to build projects on your own, or what's the coolest thing that you've kind of touched or seen at least customers be that they're building at the moment?
Well, actually, the cool thing that you can see is how everybody is basically doing its own architecture. You have different customers across different regions, and also you have different requirements when it comes to processing videos. Video is very sensitive, and actually, you feel like the big thing about computer vision is it's never the same. Every project is new. Every project has its own challenges. You have different architecture for each client. So this is what I like the most about computer vision.
Yeah, and I mean, yeah, like you said, the use cases and image quality and where like all these little things that you might not think about in other spaces of AI, you have to really consider in there, and that's really cool.
Mhm.
Some of the tools, especially the toolkit around like data generation and like, okay, if I don't have enough data, how do I can get more data quickly but using
Yes.
images, which I think that's pretty impressive. Well, I'll give a little quick, if anyone else has last minute questions, I'll put this lovely discount code or free code. I should do this more often. I really like to get people to come on the live and not just, I'll watch later. But that is going to be your discount code for getting free things. And then
Yes.
also we have that's not the right one, but I'll put it, it's the same one anyway. So link to the Toolkit docs, the Microsoft Learn modules that we also have that kind of walk you through everything that you showed, but hands-on now, which is great.
Yes.
Will be all there. And then, if we find some great Python libraries to do some distance detection and papers, I'll also throw those in there because there's some really great questions there.
Thanks. I've just shared with you the links to where you would use the code, because there is definitely a link that you.
Okay, yeah, this is good. So this find a code box somewhere in any checkout and drop that in there.
Yeah.
Okay, here we go. Go to this page here and type in this code here, and there you go. 24 hours. Time starts now. But thank you, Abu Bakr. Thank you for closing out this Building with AI products session. And thanks, everyone, for joining. You could be anywhere on the internet, but you were here with us, and I really appreciate that. Thanks, everyone.